Today we're going to talk about probability in terms of simple events, joint events, and conditional probability. Probability of A, or P with parentheses around A, means the probability of event A occurring. So that's the notation for it. Probability with parentheses around B means the probability of event B occurring. An event could be something like that you are male or female. When we look at summary tables, gender is often used as a categorical variable. So the event would be that you have a male or you have a female. In terms of Venn diagrams, where you have a universe in the box and A and B are your two events, the probability of A is shown in blue, the probability of B is shown in red. These are mutually exclusive events because there's no overlap. The probability of events A and B occurring at the same time is 0. Joint events are different. Probability of A is still shown as a shaded area in blue. Probability of B is shown as red. But the probability of A and B, that purple shaded area in the middle, looks like a little oval or football. It represents the overlap of events A and B occurring at the same time. This is also called the intersection. Now, how do we calculate the probability of A or B shown in the area in black above? Probability of A and B means the probability of event A and event B occurring at the same time. Think of it as being more restrictive. So that would be that football that was talked about just a minute ago. Probability of A or B means the probability of event B, if event A or event B can occur. Think of this as being more inclusive. So if we look at it in terms of the graphic, the probability of A or B, because we want to have everything included, is the probability of A, a simple event, plus the probability of B, another simple event, but then we've double counted the part in the middle, the probability of A and B, so we have to subtract one of them out. So minus probability of A and B. This can be seen by using contingency tables. If we have a hotel X and a hotel Y, and then whether they would come back, there was some survey that people were polled and they answered whether they would come back or not for these two hotels. The simple events in this case are I stayed in hotel X, or I stayed in hotel Y, or I said I would come back, or I said I wouldn't come back. Those are simple events. So in this contingency table, I've circled 120 and 200. The probability of A, in this case, would be people who said yes, they would come back. That's 120 people. It's 120 out of 200 total people that were surveyed, because some said no. In fact, 80 said no. So the probability of yes would be 120 over 200, or 60%. The probability of the other kind of simple event, I stayed in hotel Y, is 100 over 200, or 50%. Now, joint events would be the combination of two of these simple events occurring at the same time. So in this case, it's hotel Y and they said they'd come back. In this case, we have 65 over 200 being the joint probability of the event occurring, both events occurring at the same time, and that's 65 out of 200, or 32.5%. If you look at it from these rectangles, you can see that the double counting occurs on 65. So if A is the probability, or rather the event that people said yes, and B is I stayed in hotel Y, then the probability of A or B, probability of those who said yes to coming back or stayed in hotel Y, is 120, which is the row total for yes, 100, which is the column total for hotel Y, but we've double counted this 65 right here, and we have to take one of those out. So you'll see here that it's 120, 100, and minus 65. This comes out to be 155 out of 200, or 77.5%. So this is how you calculate the probability of an OR condition, probability of A or B. Now, conditional probability is something totally different than the simple or joint probabilities. This is where if you already know that one event has occurred and you want to know the probability of a different event occurring, this is called conditional probability. Here's another example from an economics standpoint. You have the economy grew or slowed. You have that stocks were up and down. So the probability of A would be that they grew or slowed. Probability of B is that stocks were up, stocks were down. Now you have here a different percentage depending on whether it was the economy grew or whether the economy slowed down. So you have a 70-30 split on top, you have a 20-80 split on the bottom. In this case, the probability of growth, given that stocks were up, is 70 times 70% divided by 0.49 plus 0.06. So here you have the 49, which is one way to get the stocks up, and another way is that it slowed and stocks were up. So the 55% or 0.55 on the denominator takes into account both ways to achieve stocks were up. This ends up calculating out to be 0.89 or 89%. So in summary, we've gone over simple events in terms of Venn diagrams. We've gone over joint events in terms of the conditional tables, and also then we've gone over conditional probability in terms of summary tables and decision trees.